Welcome back to P1. Today we're going to look at Unit 1.6, Rationalising Denominators. So why do we do this? Well, and what is it? Well, if a fraction has a surd in its denominator, then it's often useful to rearrange it. If a question in your exam asks you to simplify a surd or a fraction with a surd in the bottom, then you need to rationalize it. Okay, and rationalizing is essentially about getting rid of that surd off the bottom of my fraction. Now, it could look something like this, 1 over square root of something, and in which case we end up multiplying top and bottom by that square root. It could look like this, and we would need to then multiply by the opposite sign, so be a minus root b there. Or again, if it was a minus root b, we need to multiply by a plus root b and a plus root b. And we multiply the top and bottom always by the same thing, so that we are essentially multiplying the fraction by 1, so we're not changing that fraction in any way, just essentially, not changing the value of that fraction or the size of that fraction. And when we do this, this is how we kind of cancel out our surds, get them off the bottom. Let's have a look at a few. Okay. 1 over square root 5. So what I want to do here is multiply both top and bottom by the square root of 5. And 1 times square root of 5 is root 5, and root 5 times root 5. I'll take an extra step this time. It'll be root 25, which is just 5. Okay, but you should be pretty comfortable with these now. So, sorry, before I want to do equals, I want to multiply, and this is 3 plus root 2. So all you're doing is changing that sign that's between them. On the top, 1 times this is going to stay the same. On the bottom, if I look at it, I've got 3 times 3, which is 9. 3 times root 2 is 3 root 2. Just extend that line. Then minus root 2 times 3 is minus 3 root 2. And minus 2 times root 2 is minus root 4. Now what you can see is on the top we got 3 plus root 2. On the bottom, you should be able to see that these will cancel. And they'll always cancel out as long as you've got the same on the bottom, just a different sign. And the root 4 is just 2. So we're left with 9 minus 2, which is 7. Okay? So let's do this one again. Next one down, times. So we want to go root 2 minus root 5 over root 2 minus root 5. Okay, now on the top, if I multiply that, it's going to be 5 root 2 minus 5 root 5, and that's fine. On the bottom, I'm going to take a little bit of a shortcut now, so we got root 2 times root 2 is 2. When I do this one and this one, so root 2 times negative root 5 and root 5 times the root 2, they're going to cancel out. So my other concern then is root 5 times negative root 5, which is negative 5. Okay, so just taking a bit of a shortcut there. So we got 5 root 2 minus 5 root 5 over negative 3, or, swap my signs around, but 5 root 5 minus 5 root 2 over also 3. I'll give you quite a few of these to try, and then I'll go through some of the key ones in my answers at the end. Now with D here, we can multiply top and bottom by 32 and then look to simplify, but if you notice that the root 32 can also be simplified first, so in this case, if I get rid of this times sign, this can be written as 4 root 2, because 32 is 16 times 2. And then what I can do is I only need to multiply by the third part, the square root. So now I've got 8 times root 2 is 8 root 2, and then the root 2 times root 2 is 2, but I've got to also multiply by the 4, so it's going to be 8. So this is just going to be root 2. Okay, so just be careful, the root 2 times root 2 is 2, we've also got to multiply by this 4. And it's very similar in this one. In fact, actually, this is actually a really bad example because the root 63 will actually simplify to 3 root 7, so we actually don't need to do anything with that. We don't really need to rationalize it as such. Okay.